Before we look at the product and quotient rules, let's take a minute here to look at this problem. This is a good AP style problem. Has that 1, 2, and 3 options again. It says the graph of G prime is shown here. By the way, anytime you're given a graph, please make sure you note what the graph is. Sometimes it'll be the graph of the original function. Sometimes it might be G prime. Sometimes it might be G double prime. Okay, the second derivative. Make sure you pay attention to what graph you're given. Which of these is true at x equals a? All right, so here's where x equals a. All right? Now, if this is the derivative, what is true? Is G continuous?
Yeah. Yes.
Yeah. How do we know?
Because it's inclusive. It's defined in the derivative.
It's defined in the derivative, right? Remember, differentiability implies continuity. So we have a point there. Is it differentiable?
Yes.
No. Because it
There's
has
a
the
point.
sharp.
But that's the derivative graph, not the function graph.
Oh, G.
Yeah.
That's what I meant G.
If this were G, then no, there would not be differentiable here. But this is G prime. Is it defined there?
Yes.
Yeah. So yeah, it's differentiable there. Is G increasing? It has to be yes, because there's no 1 and 2 only. Oh, hey, good logic.
That's so good.
So tell me then, why does it have to be increasing other than the fact that there's no choice for only 1 and 2?
Because G prime is positive on both sides of the point.
There we go. G prime is positive right here, right? This is G prime. It's greater than 0, so that means G is increasing. Does that make sense? Okay. G is increasing. All right, so we go through each one of those. It can be tricky. It can be tricky. That's why a lot of times when I'm told, hey, the graph of G prime is here, even if they've already labeled it, I'll write it in and kind of exaggerate the fact that, yes, this is my derivative, just to remind myself. Okay?
How do you know it's differentiable there? Because isn't there a sharp turn?
Well, there is a sharp turn, but that's the derivative that you see, not the original function.
So how do you know it wouldn't look similar, like with a sharp turn?
Well, I know it won't because there's a point here. If I see a point on my derivative, then I know the derivative is defined. If there were a sharp turn in G right there, then I'd have some kind of a hole. Or maybe an asymptote or something. Okay? No. Good question. Alright, so let's talk about the product rule. We've already mentioned the fact that we've seen some like this, and up to this point we could only use our calculators because we didn't know how to find the derivative when we had multiple functions multiplied together. Okay, so here we have f prime, or I'm sorry, the derivative of f of x times g of x. And you can see we have f times the derivative of g plus g times the derivative of f. Okay? So you'll notice in each of these, we take the derivative of one of the factors and multiply that derivative by the original other factor. Okay? So, it may be easier to remember if you don't bother writing out the x's. Okay? F prime g plus f g prime. Sometimes that's a little easier to remember. Okay. You may also see this written in the dy dx kind of notation. Alright? But that's really annoying, so I'm not going to even bother writing it out. Alright? So, here's a case where I could use the product rule to find this derivative. Now you might say, well wait, isn't there an easier way of finding this derivative? How would we do this if we didn't know the product rule? Yeah, FOIL and use the power rule. So let's see what our answer should be at the end. Okay, h of x is, if I FOIL this, it's going to be 15x plus 12x squared minus 10x squared minus 8x cubed. Alright, so that gives me a 2x squared in the middle. So 15x plus 2x squared minus 8x cubed. So h prime of x is what?
15 plus 4x minus 24x.
Yeah, there we go. So now I know what my answer should be. Let's confirm that using the product rule. Alright? Now, if you were given this one and just said, hey, find the derivative, you could use whichever method you wanted. Okay? But, let's look at this. So we have f. Here's f. And this second factor here is g. Okay? So what is f prime? 3 minus 4x. Okay? What is g prime? 4. Yeah, 4. So if I am finding the derivative here for h of x, so h prime of x, I need to do f prime, so 3 minus 4x, times g. Okay, so times 5 plus 4x plus f. So we had the f is 3x minus 2x squared times g prime. Well, g prime was just 4. Okay? So, f prime times g plus g prime times f. Okay? So now we can simplify. Alright, if I FOIL this out, I get 15 plus 12x minus 20x minus 16x squared, and then distribute the 4, so it's a plus. It's a plus 12x minus 8x squared. And if I simplify that further, I get a 15. 12 minus 20 plus 12 is a plus 4x. Negative 16 minus 8 is a negative 24x squared. And that is the same thing we got by FOILing and using the power rule. Okay? So in this case, what's easier probably? It's probably FOILing and using the power rule. Okay? Yes, Gloria?
So I see that at the left side when we were using the power rule, the last term on the first line was negative 8x cubed, but on the right side we got like x squared.
Yeah, because we've already taken the derivative at this point, so that's why it's only an x squared. notice here we had an 8x cubed, but then we took the derivative afterwards and we ended up with the 8x squared, or the minus 24x squared. Okay. Yeah. I actually glanced over for a second because I saw the same thing and then I remembered, yeah, we hadn't taken the derivative yet over on that side. Okay. So let's look at one that we couldn't do with the power rule. All right. This is one that on the homework, yeah, you had on the homework, and at that point, you had to just plug it into the calculator and do calculate derivative at the point. The problem is your calculator doesn't do algebra for you, so it won't tell you what the actual derivative expression is. You'll just be able to find different points. Okay?
Not just do one thing.
Well, no, we can't just do 1 times cosine x because the product, the derivative of the product is not the same thing as the product of each individual derivative. Okay? It's not f prime times g prime. So, in this case here, our f is going to be the x, and g will be sine of x. So what is f prime? 1. What's g prime? Cosine x. So if I am getting the derivative, dy dx, I have f prime times g, okay, f prime times g, plus f times g prime. So plus f was x, g prime is cosine x. Alright, so sine x plus x times cosine x. And really that's it, just sine x plus x times cosine x. That's it. Can't simplify that anymore. Just leave it like that.
So what did you say in the beginning? It's not like the product.
It's not the product of just, it's not just 1 times cosine. Okay? The derivative, going back here, the derivative of f times g does not just equal f prime times g prime. Okay? And that's what some of you guys were trying to do, and that's very natural. I mean, I'm not surprised at all. A lot of you guys, when you saw that one on the homework, you were trying to just do, 1 times cosine. It doesn't work that way in this case.
So then, for example 1, you couldn't find the derivative of each part first, and then what?
Yeah, you couldn't just do 4 times 3 minus 4x. You had to do the full thing. Okay? All right. Let's look at one more here. Basically, what we're doing is we're learning different rules that will help us find derivatives of more and more complex functions. So here we have 2x cosine x minus 2 sine x. All right? So I know how to find the derivative of a minus 2 sine x. Okay? What's the derivative of minus 2 sine of x? Yeah, minus 2 cosine x. So if I start writing my answer, dy dx, it's going to be something minus 2 cosine x. All right? So now what I have to figure out is, okay, so this right here is 2x times cosine. So I've got to get the derivative of 2x times cosine. I'm going to call that f and cosine g. So f prime is what? 2. g prime negative sine of x. So if I'm doing the derivative of f times g, I'm going to do f prime times g, so 2 times cosine, plus f times g prime. Okay? And of course that would simplify to 2 cosine x minus 2x sine of x. So now I can plug this in. 2 cosine x minus 2x sine of x, and I look to simplify, and I see that, hey, I actually can simplify that a little bit. So my final answer is just a negative 2x sine x, because the 2 cosine minus 2 cosine cancels out.
That was just cosine x minus 2 cosine x, which would be negative cosine.
So why wouldn't you have to do a product rule for the
No, you could simplify them. Yeah.
Why
Because
would
it's a
you have to do a product rule for the negative 2 sine?
Well, because 2 is just a constant. And it's just like when you did 4x cubed. You didn't, since 4 is a constant, it was just 4 times the derivative of x cubed.
Yeah.
So if it's a constant, you don't have to use product rule. It's only when you have the product of 2 non-constant functions, could say. Okay. Now there is a pattern here that we can use to expand this or extend this. Remember I told you that with f and g, one term had the derivative of 1 with the original second function, and then you added the derivative of the second one times the original first function. Well, it also expands out if you have 3 things multiplied together. Notice we now have 3 terms added together. In the first one, we took the derivative of f. In the second one, we took the derivative of g. And the third one, we took the derivative of h and multiplied them by both the other original functions. Okay? So if I were doing the derivative of x squared times sine times cosine, this could be my f, the x squared. Sine could be my g, and cosine could be the h. Okay? So if I'm doing the derivative, the f prime is 2x. G prime would be cosine x. And h prime would be negative sine x. So then if I were getting the actual derivative, dy dx equals, I'd start with that f prime, so 2x, and in the other 2 terms I would just have the original f. Okay? In the second term I would be using the g prime, so there's my cosine x, but in the first term I would use the original g, sine of x, and in the last term I would use the original g, sine of x. Okay? And then for h, I'd put h prime in the last term, so minus sine x, but I'd put the original h in the other 2 terms. Okay? So we have here f prime times g times h plus f times g prime times h plus f times g times h prime. And then we simplify this a little bit. And we get 2x sine x cosine x plus x squared cosine squared minus x squared sine squared. If we really felt like it, we could use like a Pythagorean identity to maybe go a little bit further simplifying, but we won't bother at this point. Okay. All right, so that right there is our quotient rule. Or product rule. Our product rule. Okay. Not too bad. It is something you need to just memorize and just practice using. Okay? The quotient rule is a little bit different. Okay? A little bit different, a little bit more complicated, but still, once you get the hang of it, it's not too bad. Alright? Now, once we get to learning the chain rule, I'll actually show you how we derive this from the product rule. But for right now, we'll just memorize it. Okay, so if we're taking the derivative of f divided by g, you'll notice the top looks the same as the product rule, except it's subtraction. Okay, f prime g minus f g prime. And then you divide by g squared. Okay? So what was the derivative is now the denominator is now the denominator squared. Okay? So if you remember the similarity here, it will help. It looks like the product rule except with subtraction over the denominator squared. Alright, so with example 5 here, what is f? Yeah, 5x minus 2. So that's f. So f prime equals 5. All right? G is the x squared minus 1. So what's g prime? 2x. Okay? So now it's simply a matter of plugging in to our formula. dy dx is f prime, 5, times g, which is x squared plus 1, minus f, 5x minus 2, times g prime, 2x, all over x squared plus 1 quantity squared. Please don't forget to square the denominator. It's probably the most common mistake students will make on this, especially when the denominator already has a square in it originally. They'll forget to square. Okay. So now we just simplify the numerator. 5x squared plus 5 minus 10x squared plus 4x and that's a negative 5x squared plus 4x plus 5 over an x squared plus 1. Okay, and we're done. Oh, yeah, it's squared. I lost the
Do we
square.
leave it squared, or do we?
Don't FOIL it out. Yeah, guys, don't FOIL that out on the denominator. Leave it as just that squared. Okay? It is possible you may run into something where like this will factor and you could cancel out something in the denominator. Typically that only happens though if you have like a chain rule inside of your quotient rule, which we'll look at later. Yeah, question? Okay.
Are you doing the simplifying?
What's that?
Like you're just simplifying?
Yeah, you should take it to here at least. Combine like terms. Yeah. Okay. All right, one more. Now this says to simplify things first, okay? So what could I simplify on this one? Okay, there's a couple of ways we could simplify this. We could make it 3 minus x to the negative 1. We could get a common denominator and do some division. Okay? I could multiply it by an x over x in order to get rid of the complex fraction. That'd make it 3x minus 1 over x squared plus 5x. If I wanted to do that, I could. All right. For this case here, I'm just going to go ahead and make this a 3 minus x to the negative 1 over x plus 5. Okay? So, here's our f. What is f prime?
Three plus
X to the negative 2.
Okay. What's the derivative of 3? 0. Okay. So this is just x to the negative 2. Alright? And then if this is g, what's g prime? 1. Okay? This is why I don't multiply by x over x, because then it's gonna make things more complicated. Okay?
So if you saw it, we can leave it as a negative exponent.
Yeah, for right now, and then at the end we'll go ahead and simplify, rewrite if we need to, okay? So as I'm doing dy dx, I have f prime times g, so x plus 5, minus f, 3 minus x to the negative 1, times g prime, which is just 1, all over g squared, so x plus 5 squared. Okay? So now we can simplify a bit here. What is x to the negative 2 distributed into x plus 5?
X to the negative 1 plus 5 and 7.
There we go. Okay? Then minus 3 plus x to the negative 1 all over x plus 5 squared. We got 2 x to the negative 1s there. Well, no, it's just 2 x to the negative 1 plus 5 x to the negative 2 minus 3 all over x plus 5 squared. Now how you simplify from here is kind of up to you. At this point I could multiply the top and the bottom by an x squared. Okay? If I multiply by x squared over x squared to get rid of my complex fractions, that's going to give me 2x plus 5 minus 3x squared over an x squared times x plus 5 squared. Or if I just rewrite and leave the complex fractions, I'll have 2 over x plus 5 over x squared minus 3 all over x plus 5 squared. Really, there's no preference necessarily. I will say this. When you come across multiple choice problems, they may only offer you the first one as the option. So you're going to have, this is where it can be a little challenging. Don't be too quick on the multiple choice to choose answer is not here. or none of the above. Okay? Please check and try to simplify, see if you can't get your answer to match.
So when you bring down that negative exponent, you're putting in the numerator, right? You're not bringing it all the way down to the denominator.
Yeah. On the second option there, I'm just rewriting the negative exponents
So it wouldn't be like
as fractions.
2 plus 5 minus 3 over,
X
Uh,
2 times
X.
X minus 5 squared.
yeah,
No.
okay.